We're gonna look at stuff in that function notation, that f of x, and we're gonna do all the things you can do with functions: add, subtract, multiply, divide, and then what's called a combination function. So these are the first four things. I can take two functions, and by functions we really just mean equations, right, or expressions. I can take two and I can add them together. So if I have two different expressions and I want to add them together, I just combine my like terms. I can take two and subtract them. I would change the signs of everything on the second one and then again combine your like terms. I can multiply them, which could result in like a foiling kind of a situation, or using the distributive property. And then I could divide them. I could take one and put it over the other and simplify what you can. When you are dividing, and that's what this means, you can't have the denominator equal to 0, because what happens if the denominator is 0? It's undefined, okay? So that's all that means. You don't really have to do anything with it unless it asks you for the domain, and when we get to those, we'll go over it. All right, so we start with the adding and subtracting of two functions. So it gives me that f of x is 2x plus 1, and it gives me that g of x is x squared plus 2x minus 1. And then this first example says f plus g of x. So I'm literally taking f of x, and I'm adding it to g of x. F of x is 2x plus 1. G of x is x squared plus 2x minus 1. And then from here, we just combine our like terms. So there's only 1x squared. There's a 2x and a 2x, so it would be 4x. There's a positive 1 and a negative 1, so those are going to cancel out. This is the result of adding f plus g of x. Yep. Nope. You could factor out an x, but you don't want to. You want to leave it in the form in which it's like the terms are combined and you've simplified as much as you can. Yeah. So what's different between 1 and 2? Sabrina. 2, there's actually a value. And what do we do if I have f of 2 and g of 2? Good. I'm going to plug 2 in for x. So in the f of 2, I will get 2 times 2 plus x. I'm sorry, plus 1, which is 4 plus 1 or 5. And then in g of 2, 2 squared plus 2 times 2 minus 1, 4 plus 4. Minus 1 is 8. Minus 1, which is 7. And then the function here was to add these. So the positive 5 plus 7 gives me 12. So that's one way to do it. I could separate them out. I could say f of 2 plus g of 2, plug in the 2's into the separate ones and add them together. The other way to do it is actually find f plus g of x first, put them together, combine my like terms like we did over here, and then plug in the 2. And I would have gotten 2 squared plus 4 times 2, which is 4 plus 8, which is also 12. You could do it either way. So I would say, as an approach, if I already had to do question 1, then it's easier just to plug 2 into the already combined functions. But if you're going straight to something like question 2, it really doesn't make that big of a difference. You get to choose. Do I plug those values in and then add them at the end, or do I add the expressions first and then plug the value in? Completely up to you. All right, so then we get to 3, and 3 says f minus g of x. So similar to the first one, I'm going to combine them, but the minus means I'm going to change all of the signs in g, right, the second thing. So I could write it as 2x plus 1 minus, and I could open my parentheses and put all of g in parentheses to remind myself to distribute the negative to all of them. Or I could have just written it out. Just make sure you're careful when you're changing those signs. You're changing it on all 3 terms. Now we combine like terms. There's only one with a squared. It's negative x squared. A positive 2x and a negative 2x are going to cancel this time. Positive 1 and positive 1 gives me positive 2. So f minus g of x is that. No, you could keep it just like that. Yeah. So what's important in this question when you've got a minus is obviously the order. The order is not important when it's addition, right? Because I could switch those around. It doesn't make a difference in the signs. But when you're subtracting, you want to make sure you put whatever's first, and then you change the signs of whatever's second, because obviously that's important. All right, so now we get to 4, and I have f minus g of 2. What's one way to do this? Plug in the 2 at the end, or? Good. I can either take what we just found, negative 2 squared plus 2, and be careful here because we square the 2, then take the negative, right? So this would be negative 4 plus 2, which is negative 2. That's one way to do it. The other way is find f of 2 and subtract from it g of 2. So f of 2 is 2 times 2 plus 1, or 5. And g of 2 is 2 squared plus 2 times 2 minus 1, 4 plus 4, minus 1, 8 minus 1, which is 7. And now we subtract. So 5 minus 7 also gives me negative 2. Here.
Why can't you plug in for 2 but put it all together?
You mean add them all together?
Yeah, I put it so 2 parentheses 2 plus 1 minus 2 squared.
So you put 2 here, like that?
Yeah, but those two equations put them together.
So that's adding. You can do that here, but here we're subtracting.
Even if you put a minus sign?
You're not changing the 2, so you can't plug in a negative 2. Is that what you're doing?
No. If you put minus and then parentheses 2.
2 squared plus 2 times 2 minus 1, that's what you're doing? And then you did this, 2 times 2 plus 1?
Yeah, but together.
What do you mean together?
Without the parentheses.
So you can't, because that negative's got to go to all of them. After you square it. Because if you make that a negative 2 and then you square it.
But I did.
Let me see what you're doing.
Like this. I put the negative to all of it. Should we pause that?
But that should have been, you distributed the negative first and then plugged it in. It's fine, just make sure you don't change that to negative 2 and square it, because then the sign changes. Does that make sense?
Yeah.
You can't put the negative inside the parentheses with the 2, because then it would go away. Yeah.
So the values first, 2 away for 3.
Well, I would say that it depends on the question. To be honest, there's not a whole lot where you're gonna do 3 and then 4. You're either gonna. All right, now what's 5? What does f dot g mean? Multiply. It would be the same if it said f, g up against each other like that. Those would be the same thing, okay? So now I'm taking f, which is x squared, and I'm multiplying it times g, which is x minus 3. And then what? Distribute the x squared in. So x squared times x is x to the third, and then minus 3x squared. And that's as far as I go with that. So f times g up against each other, same thing, right, of 4. Now, again, we have 2 options. I could take this, which is already the f times g, and I could plug 4 in. So it'd be 4 to the third minus 3 times 4 squared, or 64 minus 3 times 16, 64 minus 48. Or I could do f of 4, figure out what that is, and multiply it times g of 4. So f of 4 would be 4 squared, which is 16. G of 4 would be 4 minus 3, which is 1. 16 times 1 is 16. So same answer either way. Again, if I already did the f times g, it might be easier to do it the first way. But if I'm going straight to f times g of 4 and I didn't already combine mine, I would probably do it the second way. But it's completely up to you. And shoot, if you had the extra time, you could do both and check. All right, now, what am I doing? Dividing. So notice that the instructions got added. Find the combined function and then the domain. So we're going to first combine them and then we'll talk about domain. So the first one is f over g. So my f is square root of x. The g is the square root of 4 minus x squared. Can I simplify that? There's nothing I can cancel, right? I can't cancel the x from the top into the x squared on the bottom. That stays that way. Now let's talk about domain. Yep. No. Did you hear that, Miss Fair? Would you have to rationalize it? No. Then you've got the domain. So what are our domain restrictions? What are we looking for? What are the 3 cases where it's not all real numbers, Samuel? So there's a square root in the top. That has to be greater than or equal to 0. And the bottom, it's greater than 0. Yep.
Why wouldn't you just square the whole thing to get like x?
Because you can't, there's nothing on the other side to square to balance that out, right? You can't just change a half of a, yeah. All right, so that's based on the combined function, right? So I'm going to take the top, and I'm going to say x has to be greater than or equal to 0. And I'm going to take the bottom, and I've got a squared in the bottom and an inequality. These are the yucky ones, right? What do we do here? What happens when you have a squared and an inequality? Sophia.
Do you factor?
You can factor this, so I would get 2 plus x and 2 minus x, and then I get 2 answers, right? Negative 2 and positive 2, but what do I do with those 2 answers? I have to put them on the number line and test my point, right? So I'm going to put them on the number line, negative 2, positive 2. I'm going to plug in 0 to make my life easy into this statement here. So 4 minus 0 is greater than 0. Is 4 greater than 0? Yes. So if it was just the bottom, then my domain would be from negative 2 to positive 2, parentheses on both because it's not or equal to. But it's not just the bottom, right? It also has the restriction of greater than or equal to 0. So that would be a bracket at 0, and I would point it right. How do I know what part of this to keep? Only the overlap. Good. So it's going to be actually from 0, right, with a bracket, to positive 2 with the parentheses, shaded in between. So it's 0 to 2, bracket on the 0, parentheses on the 2.
When you put your 0, that's when you
Yep.
put it where the 4 minus x squared is, right?
Right, because that was the one we're testing. We're only testing the denominator. Only where it's squared and inequality. The top we didn't have to test. All right. So what does 8 look like before we find the domain? What's in the numerator this time? That g, so 4 minus x squared. What's in the bottom? Square root of x. How does this change what we just did? So that's the answer for the first part. Good. Now the bottom is the greater than and the top is the greater than or equal to. Do I have to go through all that work again? No. It just changes your brackets and your parentheses. So I would still, from my numerator, have negative 2 and positive 2. I would still plug in 0, and I would still get 4 is greater than or equal to 0, which is a true statement. But now those have brackets. Then comes the bottom, greater than 0, parentheses to the right. So my overlap is still from 0 to 2. The difference is now the 0 gets the parentheses, the 2 gets the bracket. Questions? I think that's like the hardest, this and one more thing are like the hardest part because you're going back to your domain, your overlaps, your graphing. The rest of this section is not that bad.
Would it
Yeah.
be a question where you like simplify the
No.
stuff?
Mm-mm.
Leave it unsimplified?
Yep. You would leave it like that. Yeah. All right. The last kind of function combination that you can do is f of g. I taught this for like, I don't even know, like 5 years ago. We were like all the way at the end of the chapter and somebody called it fog. And they were like, how do you do that fog thing? And I was like, no, that's not it. Oh, that means something, right? But it is different from multiplication. So that open dot is not the same as multiplication. It does not say take f and multiply it times g. What it says is in words, f of g of x. So f of g of x means I take the g of x and I plug it into the f of x. So whatever's on the right or whatever comes last or whatever comes second, that's the thing you're going to plug into the one on the left. You can always take a statement like this and rewrite it as this if it confuses you. So if I had f of g of x, then it's f parentheses g of x. And then that tells you I'm going to take what's on the inside parentheses and plug it into the one on the outside. The order of the letters is obviously important because if I switch that around and I say g of f of x, I'm taking the f of x and plugging it into the g of x, okay? They look like this. So at the top, you're still given f of x and g of x. F of x is x plus 2. G of x is 4 minus x squared. And 9 says f of g of x. So I can rewrite this as f of g of x like this. Which one am I plugging into which? Good. This g of x, this whole thing is getting plugged into the f of x where the x is. So that x is getting replaced by g of x. So I would get 4 minus x squared plus 2. Are there terms I can combine? Yep. I'd get negative x squared plus 6. And that's as far as I can go. You can rewrite that as 6 minus x squared. It's the same thing. The order there doesn't matter. Go to 10. This time, which one am I plugging into which? Good. The other way around. The f is going into g. So the f of x, that x plus 2, is getting plugged into the x squared. And I'd get 4 minus, in parentheses, x plus 2 squared. Do I distribute the exponent? No, I do what? Good. Expand and FOIL. So this becomes x plus 2 times x plus 2, or you could use your shortcut. 4 minus x squared plus 4x plus 4. Because you square the first, square the last, double the product on the inside. And then they all get the minus. So it would be 4 minus x squared minus 4x minus 4. And the 4 and the negative 4 cancel. I'm left with negative x squared minus 4x. What changes? Oh, sorry.
Are you allowed to just divide it all by -1?
No, because you can't. There's nothing on the other side, right? Like if 0 was on the other side, sure. Right? But you can't just take an expression and alter it like that. You could take out a -1. I could write -1 parentheses, but then what's the point? Yeah. All right, so then what's different with 11? Sophie. You have a value there. So if I rewrite this in its parentheses form, it'd be g of f of -2. And then we follow the rules of parentheses. It says to do the innermost one first, right? So I'm going to do this. I'm going to take f and I'm going to plug in -2. So f is up here. Oops, f is up here, right? I'm going to take that, -2 plus 2, and I get 0. And that replaces this whole parentheses. And now I find g of 0. So I go to my g, 4 minus x squared, 4 minus 0 squared, which is 4 minus 0, which is 4. Now this is not a 2-part answer. That is your answer, the last thing that you get. So you're going to do whatever's inside the parentheses first, take that value and plug it into the one on the outside of the parentheses. So if the letters were reversed, if it was f of g of -2, I would do g of -2 first, get my value from that, and then plug that in to the f. So innermost parentheses first, just like a normal order of operations. Questions on those? Everybody still doing okay? Yes? All right. All right, so the first one, which one are you plugging into the other one? G, good. G goes into this one. So 2 times 4x squared plus 1 plus 5. 8x squared plus 2 plus 5. 8x squared plus 7. Raise your hand if you got it right. Good. All right, then g of f of x. So the order looks different. The format looks different than something that would be g of f of x, right? But it's the same thing. So I'm taking the right side, plugging it in here. Now the order switches. So the f goes in to the g. And I'd get 4 times 2x plus 5 plus squared plus 1. I want to expand and FOIL the 2x plus 5. I'd get 4x squared plus 20x plus 25 plus 1, and then distribute. 16x squared plus 80x plus 100 plus 1, 16x squared plus 80x plus 101. Questions on that one? Again, raise your hand if you got it right. Okay, perfect. Good job, guys. All right, last one is f of g of negative 1/2. So I would rewrite it if it confuses you. If you like the parentheses, do it. The negative 1/2 goes into the g. So into my g goes negative 1/2 squared plus 1. This is 4 1/4 plus 1. The 4 and the 1/4 reduce to just 1 plus 1, which is 2. That would be g of negative 1/2. Now I have to do f of 2. And f is 2 times 2 plus 5, 4 plus 5, which is 9. Everybody good? Yeah? Okay. So the last thing in this section is dealing with what we just finished, except it's domain of that composite function. So the domain of the composite function is based on the end result, just like it was with the division, except there's a special case here. When you're dealing with your composite function, so the f of g of x or g of f of x, not only do you account for the domain at the end, which is the end here, the results from the composite, whatever the end result is, you look at that domain, but you also have to carry down the domain from the beginning, from the second function, the one on the right. So if I had f of g of x, and I want to get the domain, I'm going to combine them together. I'm going to look at that end result and see if there's a domain restriction. But then I also have to go back to the one on the inside or the one on the right, g of x, and see if there's a domain restriction there and include that as part of my domain restriction. Now the reason is because think about it. If I had f of g of 2, let's say, I have two ways of doing this. One is take the 2, plug it into the g, take that answer, plug it into the f like we've done. But I could also find f of g of x and then plug the 2 in. So I have to account for that domain from my combined function, whatever I'd get at the end, and also whatever's on the inside. So if it was g of f of x, I have to go figure it out, go to the end, see if there's a domain restriction, but then go back to the one on the inside or the second one and check that domain restriction too. We're going to do it so that it makes sense, okay? So f of g of x and then the domain. So let's do the easy part first, right? Let's take the g and plug it in to the f. So I'd get the square root of 9 minus x squared minus 9. What happens when you square a square root? It goes away, and I get 9 minus x squared minus 9. And then 9 minus 9 cancels out, and I'm left with negative x squared. So this is the end result of my combined function. Is there a domain restriction on that? No. No variable in the denominator, no variable in their square root. The domain on that would be negative infinity to positive infinity, right? But we now have to go back, because it's the combined function, to the one that's in order second or last, which is the g of x, and see if there's a domain restriction from my original function. Is there? Yeah, that's got to be greater than or equal to 0, right? We would factor it, 3 plus x, 3 minus x. I'd get negative 3 and positive 3. I'd set up my number line. I'd plug in the 0 in here. 9 minus 0 squared greater than or equal to 0, and 9 is greater than or equal to 0. So I would keep the middle part. So if there were two restrictions, if I had a restriction, I think which is the next example, if there's a restriction here and a restriction here, we graph it and only where it overlaps is what we keep. This time there's only a restriction here, so we only have to worry about that one. So the domain is from -3 to +3. So the process again is do the combined function, look for the domain restrictions on the combined one, and then go back to the second function in your statement and check to see if there's a domain restriction on that. Samuel.
All the numbers so that you forget
If you think about it, if we graph this on the number line, it would be the whole number line, right? But then this says just from -3 to +3. We can only keep where they overlap, which is just from -3 to +3. So I think I'm going to run out of time. I'll do it on the video. But let's just talk about what would be the restrictions here. So this would be square root of x. F of g of x. I'm going to take this and plug it in here. So I get square root of x squared plus 4. Is there a domain restriction there? Yes. Well, let's figure it out. This has to be greater than or equal to 0. I get x squared equals -4. What happens when I square root that?
You can't do it.
There's no i's on these, right? So there's actually not a domain restriction. Does that make sense? There's no value there. That's a real number because it's a plus. If it was a minus, then I'd got the -2, +2, and I graph it, right? So even though it appeared as though there was, because there's no real number to actually plug in there, there's no domain restriction on the combined function. So then we have to go back and check the initial domain restriction on the one on the right, which is my g of x. And because that's x squared plus 4, there's no domain restriction there either. That would be -infinity to +infinity. So the overlap here is the whole thing. -infinity to +infinity would be the domain of my combined function, which was this, the square root of x squared plus 4.